All right, good afternoon, everybody. Welcome to another live stream. So today's going to be an exciting one. It's going to be a busy one. We have a lot to cover today, so we're going to just kind of jump right into things. So, what are we covering today? So today we're going to cover some more of the advanced features of LangChain. Now, it's been a little while since that I've realized that since we did our original introduction to LangChain, I think that was like 2 months ago now. But no worries if you missed that one. You can always go back and view that one. But what we're going to be covering today, I'm going to be trying to explain clearly enough that even if you missed the first one, it's not a big deal. But I'm going to be covering just a smorgasbord of really cool features that LangChain has to offer today. Now, the one thing I do want to address before we get kicked off, in case anybody's curious, is I had a tentative live stream scheduled for last week around LangChain agents, and I canceled that. And so basically, maybe I'll give a longer explanation toward the end of the stream today if we have time. But the short answer of that is I basically couldn't get it working. So the very general gist of what an agent is basically an LLM that you kind of give a task and it keeps going around and around in a loop until it converges on the final task. Like, it's designed for more complex kind of tasks. So basically, like, mine would never converge on the final result that I wanted it to. So I think I want to leave it there for now. Like, maybe if we have time at the end, I'll say exactly what I'm trying to do. I'm not trying to hide anything. I just got a lot of things to cover today. So let's just go ahead and jump into the code. So let me pull up my screen. Okay, so today we're going to be working out of a Jupyter notebook. So not doing anything particularly fancy. I've got my Jupyter notebook here started. Nothing going on here too much. Haven't even done any of the imports. That is one thing I'm glad I just remembered. So if you're trying to follow along today, please make sure you are using the latest version of LangChain. And the reason I say that is even I had an issue whenever I was trying to play around with one of these functionalities, I think a couple days ago, where I was trying to make it work and it didn't work, and it turned out it just that I was not using the latest version of LangChain. So if you are using pip, it depends on what you use. So in order to do that, like, what you can do to do the upgrade is LangChain upgrade, and that should be it. Oh, look, even I'm out of date. A very minor out of date, so I don't think I'm probably missing anything here. So I actually just ran all the code that we're going to be running this morning, so I know we're good to go. Okay, so what do I want to cover first? Oh my gosh, so much stuff to cover. Now, so if you saw me post the picture to LinkedIn this morning, I shared a lot of different imports that we're going to be doing, using along the way from LangChain. For the purposes of this stream, I am not going to throw them all up in the top cell like I usually do, and that's just because there's so many of them. And so one thing to note also is we've been having some weird weather here in Bloomington, so I'm hoping that there's not like a storm or anything that would ever cut me off. But just in case that does happen, I just wanted to point out over on my GitHub in this LangChain tutorial GitHub repo. I almost said GitLab. Everything that we're going to be covering today is already done and uploaded to GitHub. So if we get cut off, or if you want to review what we did today, it's already there. So in fact, I'm not going to be reading. I will be typing things out as I go. But basically, we're going to be basically cover this entire notebook here, if we can. But so you can see how many imports there are. But we're just going to import stuff along the way, just so we don't trip ourselves up and we know what each of these things are doing. Okay, so with that, the other thing of note is behind the scenes, we will be using the OpenAI API. This is one of the great things about LangChain. It really does not matter which LLM you use. If you have a different API preference, or if you have your own local hosted machine, so I actually do have Llama 2 running, not currently, but it's running on my MacBook. It's not running right now because I'm honestly kind of afraid if I turned it on that it would break. Like, I got too much stuff running on my computer that would break the stream. So we're just going to use the OpenAI API. So if, again, you're welcome to use anything. But if you do want to follow along specifically with my set of code, just make sure that you have an OpenAI API key. And just be cognizant of the fact that if you do choose to go that way, it will cost you a little bit of money. But I think I did so much testing with OpenAI last month, and I think my overall bill was like $3. So less than a cup of coffee. And again, I've showed you before in previous streams how on OpenAI it's really nice where through the API you can set your budgeting threshold. So, if you set it to $10, which is what I personally have it set to, then it just cuts you off. So, I say that just because if we were working on a cloud like AWS or GCP or something, I know that those builds can get really scary, especially if you don't manage those. OpenAI is very good about that. Okay, so enough waffling about that. So basically what I did here is, let me make this a little bit bigger for y'all. I am just loading in my API key from a YAML file and then setting it as the environment variable here. You could just set it as the environment variable right out the gate if you wanted. The only reason I'm doing it as such is, if you work in a corporate environment, like I do, then you're not going to be setting an environment variable per se, like right out the gate. Instead, what you'd probably do is whenever you start up your endpoint or however you would be hosting LangChain, at the point of runtime, you'd probably load in the API key from something like Vault or something like that. So that's why I'm kind of emulating this here, is because if I was loading this from Vault, I would probably just replace this line with the load from HashiCorp Vault and be on my way. Okay, so let's go ahead and jump in. So the first thing I do want to cover very quickly, and I'm just going to brush up against it just because I don't really know a whole lot about it, and it's also currently in closed beta, so it's not really useful to you, but I wanted to expose it to you anyway because I think it's pretty cool, and I do want to delve into it more, and that is what is called LangSmith. So LangSmith is a new product being developed by the LangChain team, and I think that it's a multifaceted tool, but the one way in which I've been using it is sort of like a very nice user interface debugging tool. And so the way that so like I said, it is in closed beta right now. Unfortunately, I do have access to the closed beta. They were very kind enough to provide me with this access. And so basically this is the user interface here. And in fact, let me go to the home screen. So I actually don't know what this stuff down here does. I kind of want to learn about it. It seems pretty cool. But what we can do in here is we're going to instantiate some API interface like things, and is basically just going to log all of our runs and stuff for us along the way. In fact, I just want to show you really quick here. So this is this thing called Movia Trivia here. This is the agent that I kept trying to get working, and you can see that as I start to expand some of these things, you can see where I was trying to do things like chain LLMs together with Google search and list parsers, and it just kept failing on my output parser here. It just kept wanting to invoke this too soon. And again, I don't want to talk about this too terribly much right now, but LangSmith can be really cool, and it's very, very easy to set up. So let's go ahead and set it up for this project just to show you what it's like, and then but we'll just keep moving on for now. I just wanted to expose it to you really quick. It seems really cool. Check it out, but I don't want to dwell too much time today on it. Partially because I don't know a whole ton about it, and partially because it's still in closed beta. All right, so I'm going to be setting the environment variables required for LangSmith. And just for your all's sake, let's turn this into a header. All right, I'm going to call this LangSmith. Okay, all right, so we need to, I'm just going to do a copy and paste here because there's nothing really special going on here. The only thing that I'm going to change here is, so I am going to change, so you notice you can tag like certain projects on this. Just for clarity's sake, I'm going to change this to advanced live stream notebook. Okay. And then I do have my API key saved in the save YAML file. Again, you'd probably want to load that from someplace else. I did ask the LangChain team if LangSmith would ever be available for offline usage, because this is all being done like in this user interface over here. They said no. I believe that I don't want to quote them on this, but the way I interpreted it is that it seems like they want to monetize this as a product here. And, one of the people did reach out to me and say, if you want to self-host it, then we can talk. But just be aware, so this may turn, this whole LangSmith product may turn into a paid product. For now, it's free through closed beta, but again, you do have to apply for that. Okay, so I have my API key here again. We can go ahead and run this out, and that's all you got to do to get LangSmith going as far as the logging stuff. There's nothing else. So that's one thing I really do like about LangSmith. It's boom, generate your API key, paste a couple of environment variables in here, and you're on your way. All right, so that's LangSmith. So let's actually jump into some of the cool things about LangChain today. Oh, there is one other thing I do want to mention. So you might be wondering, are we going to be covering anything around vector databases or vector embeddings or, smart search with LangChain? I am purposefully going to hold that one off because I think that one deserves its own stream. So I am going to do a separate live stream on that at some point. So today we're going to be covering other things. So the first thing I want to cover here is, let's say you want to develop a generic chat interface and, not a generic chat interface, but you want to have a chat bot very much like ChatGPT or Google Bard, and you want to have it with a custom or like a custom tone or a custom role. So like, you know, if you paid attention to any of these streams before, the silly example that I always love to use is, you know, can you answer all these things as Jar Jar Binks from Star Wars? So so we're going to cover like a more complicated version and a simpler version. So let's actually start off with a more complicated version of that. So the first thing that we need to do is we need to instantiate our LLM object. So again, like I said, we are going to be using OpenAI. So I'm going to import this. I got to read where the import's at. So import, from LangChain chat models import chat OpenAI. So this here represents LangChain's chat to interface for the OpenAI API. And since I've already set my environment variable up here as so, I don't really need to do anything else other than just go ahead and instantiate the object. So let's go ahead and call this LLM equals chat OpenAI. Okay, there you go. All right, so that's step number one. So the next step here is we need to set up our prompt template. So what this is going to be here, you know, I actually want to, I'm looking at my notebook down here, and I kind of want to do this a little bit out of order. So the first thing that we need to be mindful of is whenever we interact with ChatGPT or Bard or any of these interfaces is what most people might not realize is it's actually not saving a state of the conversation per se. Like, of course, yeah, if you're familiar with ChatGPT, you can look at your chat history. But in terms of interacting with the model itself, it's not as if our conversation is being saved in memory on the RAM of this hardware somewhere. What we're actually doing is we're passing back through the conversation, the whole conversation every single time, which is why context length is an important consideration when interacting with LLM. So context length, again, if you're not familiar with what that is basically how long of an input you can give into an LLM. So there is a cap on it. Some models have a little bit larger of a context window than others. And some are a bit shorter. But you do want to be mindful of that sort of thing. So, because if you accumulate too much history, then you accidentally top out how much context you can pass in. So in terms of that, let's go ahead and set a memory object. And I want to talk about this memory object because this is a generic one, but this is something I actually didn't put in my notebook here, but I think it's worth talking about. So I'm going to instantiate a variable called chat history, and this thing is going to chat history equals, I got to import something. Here, let me make another header here just to be really clear for y'all. All right. I'm going to call this creating a chatbot interface with custom tone. Okay. All right. So that is that. All right. So what was I talking about? Oh, I want to import something here. All right. So from, did I accidentally, oops, didn't mean to do that. From LangChain.memory import conversation buffer memory. Well, actually, you know what? Before I tab over there, so you'll notice as I was tabbing here that there's actually a number of different of these memory kind of objects, and we're just going to start off with the basic one for now. So the basic one is this buffer memory, and we'll proceed forward. So what we're going to do here is we're going to say chat history equals conversation buffer memory, and then we do need to pass in what is referred to as a memory key. So this is going to reference what the name of the memory is. So I'm just going to call it chat history, and this probably doesn't make sense right now, but it will make sense here in a minute. And we're going to say return messages equals true. Okay, so what this it might help if I ran this all up here. All right, so what this is doing here is this is going to store the conversation history of our chat conversation here. And the cool thing about this is you can actually do a number of things with this object. You can you can extract out the messages themselves. You can actually save it as a JSON file. So if you wanted to save the conversation and load it up in a different interface, you can do that. Or very similar to the ChatGPT interface. Let's say I have a conversation right now with ChatGPT. I walk away for a week and I want to pick up right where I left off. Well, if we save this conversation here in this using this memory object, then we could easily load it back up from some file somewhere and be on our way. Because remember, again, every time we interact with a model, we are passing back through the entire chat history. So we could be theoretically 1,000 days from now, load up that same chat file and be on and have that same conversation flowing as if no time passed at all. All right. Now, so this is the most basic version of the conversation memory. There are a couple other cool memory objects. In fact, let me try to pull one up here. Like, I actually have not tested out with this other one, but I really want to pull it up. All right, LangChain, memory. All right, memory types. Okay, so so this is the basic one. It's just storing the memories and then extracting them as variables. Oh yeah, that's the other cool thing is you can extract them as variables if you want. But the other one of the other cool memory things is what this one here that I've not really played around with yet. So what this one is doing here, this conversation summary memory, is like I said, if your context window gets too long, you will have a problem when you try to pass back through all your history. So there's two ways you can kind of get around this. The first way is to just start deleting some of the earlier message from the history. That's one way to approach it, and that's not a bad way to approach it. But you are obviously losing an early part of the conversation. Another way you can do it is with this conversation summary memory object. And again, I actually did not program with it, but I understand the concept of what it's doing because you can see we're passing in an LLM here. What this is actually going to do is it will take the like long running history of your conversation and summarize it using the LLM, and then just keep like a truncated version of that summary. So it like I think it does save just like the last couple recent like chat back and forths or however you want to call that, the back and forths, like the last 3 or 4, but anything that's older than that goes into the summary. And so then theoretically your memory is like indefinite. Now, when I say theoretically, obviously when you do that summarization and the truncation, you are obviously losing some sort of information. And there's trade-offs to doing both of these. So the trade-off here is, you are doing a summary, but you, again, are using an LLM here. So, the summary could be prone to hallucinations. So that's one thing to be mindful of. And then, but using the other object here is, if you have a long-running conversation, then you will start to lose some of the early parts of this conversation. Now, honestly, in most cases, I think this is probably going to be fine. I don't know many people that are really, really concerned with a long-running conversation, which is why we're going to stick with this one. It's also the most basic. And you saw that there were other ones based off tokens. There were others based off of vector store back memory. I honestly don't know what that is doing too much, but yeah. So this is the object here. So now let's go ahead and develop a prompt template. So we are going to be using the chat prompt template. So we need to import another thing up here. All right. So I'm going to go to here from LangChain dot prompts import chat prompt template. Okay, so this is the desired template to use whenever you want to have a chat conversation with one of these models. And again, one of the great benefits about using LangChain is it does not matter which model we use. This is going to translate across all of them, which is a great way to test things out. It's a great way to make sure that your code doesn't get too messy when you have to go back and change things and whatnot. And yeah, you could code this yourself. However, I'm going to just guess that LangChain is probably doing it better than most people can because they have so many eyeballs on it. I actually just saw a thing on Twitter this morning, or X, my apologies, that like LangChain is like the fastest growing library in the generative AI space, like by a mile. Like, so, and even, the infamous Andrew Ng, who's produced a lot of great courses on Coursera, part of Deep Learning on AI, partnered with Harrison Chase, CEO and founder of LangChain, to produce their own little course. I would actually recommend you go and do that. We're going to be covering some things here. It's a short course. It's free. I think it's like an hour. I don't think it necessarily is going to cover, like it does talk about agents, and I'm not really going to talk about agents here. It covers a little bit more than what I'm going to cover. And so that's a great resource. Might I also recommend Perion Training's course on Udemy around LangChain. So if you don't know Perion Training, you might know Jose Portilla, who's the instructor for that. He does a lot of courses on Udemy. He did a fantastic job with that course. That one's a little bit longer. That one's like 6 hours, but that one is well worth it. So yeah, I am doing a lot of talking and not a lot of coding. All right, so let's get back to the prompt template. So I'm going to call this prompt template prompt template equals chat hold on chat prompt template. All right, so we need to pass in our messages that are our prompt messages that we want to leverage here. Messages equals, and it's going to be a list of these things. So the first thing that we want to do, if we are going to set a like a custom tone to the thing, so again, like we're going to use just the stupid Jar Jar example. Like if we want this thing to answer everything as Jar Jar, we want to actually set what is called the system prompt template. Which means I'm going to need to import some other things. So actually, let's go ahead and import all these other things at once. So what we're going to actually need, and we'll talk about these here in a little bit. So we're going to need system prompt template, or system, is that right? Oh, system message prompt template, my apologies. Messages placeholder. That one's probably the most ambiguous, but that'll make sense here in a second. And then the human message prompt template. So I'm going to import all three of those because we're about to make use of these all in the same cell right here. All right, so let's go ahead and set our system message. So system message prompt template dot from template equals you answer all questions or inquiries as jar. Here, let me move my face. We're gonna get in the way here. All right, moving myself out of the way. As jar Binks from Star Wars. Jar Jar Binks from Star Wars. Hold on, I can't see my screen. Why can I not see my screen? Oh, by the way, if anybody has any questions along the way, feel free to ask, because I just noticed there was a question. Is this session recorded? Yes, these sessions are always recorded. You can always find the replays either on LinkedIn or YouTube. Transparently, LinkedIn's great, but it's easier to scrub back and forth through the video on YouTube, in my personal opinion. So it is being recorded live in both places, and I never edit these things, so like whatever flubs there are, they will be there. All right, so I'm trying to figure out what I typed here because I can't see my typing. All right, you answer all questions as well. What am I doing here? I could just look at my other notebook. Sorry, I'm looking at my bottom screen here trying to figure out what I typed because I can't remember if I need to put like a variable thing in here or not. All right, so what did I type in here? All right, you answer all. Okay, that's all I did. All right, so is that all I did? Did I already have it? Okay, so it was already good. All right, now I feel stupid. All right, anyway, so moving on. All right, so that's system message prompt template. So the next thing we're going to pass in here is this nebulous looking messages placeholder. And so what the messages placeholder is actually doing is this is the way that the history comes back into play. So we're going to say, so what we're going to do is we're going to say messages placeholder, a variable name equals chat history. And this is why I chose to instantiate the chat history object first. So then we can start to piece these things together. So what's going to happen here is every time we fire off this prompt, why is there like a missing, I probably got something mismatched here. From template, oh, that equal should not be there. That's why. Well, that's one of them. All right, from template, messages placeholder, variable name. So, okay, sorry. So you can see how we are connecting the chat history to here. So basically every time this is run, what it's doing is it's first noting that, hey, you are Jar Jar. Then it's going to pull in the chat history here. So if there's nothing, then there's nothing. And then the third thing we're going to do here is we are just going to define a human message prompt template. And you do have to put this in here, but this is just going to be an empty thing for us. So we're going to do .from template, and that is quote, quotes, question, and that's it. So and this is another input variable. So that's the template, and I feel like I did something wrong here. All right, system message prompt template from what did I do wrong here? I don't know. Oh, do I need to put commas after? Oh yeah, this is a list. Duh. Okay, yeah, this is a list of objects. That's why. Need the commas there. All right, so there's the prompt template. We already instantiated the conversation history. So the next thing we need to actually incorporate our LLM chain. So I need to do another import, and I'm kind of regretting how I've structured this thing so far because I don't like having to go back and re-import things, but I also want to make it a little bit understandable. So LangChain is it chains? From LangChain.chains import LLM chain. Okay, so this is our LLM chain object. And so we are going to instantiate this with a couple of things going on in here. All right, so the first thing, so we're going to call this conversation chain equals LM chain. LLM is LLM, so recall that we already defined this above. This is the chat object. All right, so the prompt is going to be our prompt template that we defined above. Memory is going to be our chat history, and we are going to set this verbose equals true. And we, again, if you don't have to set this last flag, this is just going to show us what's going on here. All right, so that's the, oh my gosh, that's going to drive me nuts. All right, so instantiating the LLM chain. So let's go ahead and print out the results of, we're going to ask 2 questions back to back. And I'm asking these 2 questions on purpose. In fact, I'm just going to copy and paste these because there's nothing special about the code here. All right, so let's test out a conversation chain. So we're going to ask 2 questions back to back. So we're going to ask, what is the capital of Illinois? So the capital of Illinois, if y'all think back to your grade school days, is Springfield. But then notice how I phrase this next question. I ask, what is the largest city in that state? Now, the only way the LLM is going to know what is that state referring to is if it knows that we're talking about Illinois. And the only way for it to know that we're talking about Illinois is if we instantiated our memory object. So what's going to happen here is we're going to pass this question in through this chain here. So recall here that we have labeled this as question. So that is where this is going to come in here. So basically this first one is going to be, you answer all the questions as jar jar. And then we pass in our chat history. First time is going to be nothing. And then the second time is going to be the question. I'm sorry. The first time is going to be nothing. And then we pass in our question. And then the next time we pass this thing through is it's going to show, again, you are jar jar, but this time it's going to load in the chat history. So it's going to load in this first question along with the AI answer, and then it will ask the question again. So let's go ahead and run this. And then again, we did set this to verbose equals true just to show, so you can show what's going on. So you can see, all right, we are answering all questions as such, and you can see that we have this object here. And so did I not print this out the best way? I guess I didn't print this out the most ideal way, but where is it? That's weird. Oh, there it is. So you can see that Jar Jar did guess correctly that we do live here in Illinois. And then you can see here in this chain, I guess I just printed out the whole response object, which includes all of the chains and stuff. So you can see that we got the human message. And then we are scrolling over a little bit. We have the same answer from Jar Jar. But if we scroll even further, we should see that Jar Jar knew exactly that this was indeed Chicago. So if you want to look at the history object, you can do that. All you got to do is go to chat history dot load memory variables, and then this is going to be the weird thing is you just have to pass in a set of empty curly braces, and then it will show you the chat history as all these different objects in LangChain. And like I said, there are different like functions and stuff where we could save this as JSON, we could save this as another structured file. So if we wanted to have a continuous conversation going forward, we just save that out into some place like, I don't know, S3 or someplace, and then we load it back up, and then we can continue our conversation along the way. So that is a very, very basic chat interface. So now let's say you don't really care that Jar Jar is talking here, and you just want to like stop, not even worry about any of this baloney, and just move on to a very, very, very basic chat thing. There's a way to do that. So that is we're going to call this our simple chat bot. I just wanted to show this first because showing the simple chat bot will kind of make things, and this kind of make things make sense. And this is actually how LangChain themselves explain it in the notebook. So again, we have to do another import. So we need to import the conversation chain. So conversation chain. Okay. All right, there's that. Load that in. All right, so let's go ahead. And this, I think I tweeted this or something like yesterday. So in order to build this one, all we have to do is pass in our LLM, and we're going to call this simple chat bot equals conversation chain. And then we're going to say LLM equals LLM. All right, that's it. There is nothing else going on here. It already has all the prompts and stuff set up there, but they are default prompts, so you're not going to get any special Jar Jar anything going on here. I believe it is using the conversation buffer history object, the simplest one, as the backend here. But basically, we can emulate the exact same functionality. So I'm going to ask. I'm going to just copy and paste this simple interaction here that I'd shared yesterday. So again, I'm just copying and pasting the stuff that you probably already know and don't care about. So if I ask again, what is the capital of Illinois? So you can see that the AI responds it is Springfield. Again, there is no special formatting here because we have no jar jar here. And then you can see again, we are just asking it. So it's giving back the response as Chicago. So if you want something that's just very easy to get up and going with, and you don't care about the fanciful things, this is fine. I would personally recommend this other way, just because A, it's really not that hard to get up and going, and B, if you ever decided later on that you did want to add some flexibility, well, now you just go and update your little template thing here and be on your way. Whereas if you started here and you wanted to add some customization, well, now you got to go add in some additional stuff in there, not additional stuff. You have to go and do a little bit of a refactor. All right, so that is number one. Number one of the 4 things that I wanted to get to on my list today, and I am not sure we're going to get to all of them, which is kind of a great problem to have. Actually, I'm looking at this. Some of these are pretty. Actually, this next one's probably the most complex. All right, so the next one I want to talk about is few-shot prompting. So actually, let me Google few-shot prompting. I found a few-shot prompting. All right, because let's learn about the intuition of it before we try to program it. So few-shot prompting is basically the idea where we give the model several questions and correct answers in a back and forth kind of thing, and as we feed it into the model, and then as we ask another question, the goal is that based off of those few examples that we already gave it, it will emulate another example very much in line with that one. So I'm going to do this is really easy to do with LangChain, and I'm going to do a really kind of silly, kind of stupid example. All right, and if you've already looked in the notebook, you already can see what we're going to do. So just again, for your sake, let's make this a header cell. Let's call this few-shot prompting. Okay, this is markdown cell. And we got Python cell. I got to take a swig of my water since I'm no longer allowed to have too much pop or soda, whatever you all want to call it. All right, few-shot prompting. So what I am going to do here is I'm going to pass in a list of dictionary objects, and basically these are going to contain our few shots, and what the hope is that on the 5th shot, because I'm passing in one, well, let me count, 1, 2, 3, 4, then on the 5th shot, it will see what I'm trying to do here. So, and there's a reason I haven't pasted it in yet, because it's really stupid. Okay, all right, whoops, it copied in a little too much, all right. All right, so basically what's going on here, let's read what we're doing here, is when I say David, you say Hundley, and then every time I say David from this point forward, you say Hundley again. So again, this is a really stupid kind of example, but you can see that we've set up a few examples of it. So I'm a human, it says Hundley. I say David, and then it says Hundley, and then I say David again, and it says Hundley, and then it says David, and it says Hundley times 4. And so the goal here is, can we get it to say David? If we say David, will it say Hundley again? And the answer is yes. So let's go ahead and so this is a list of just dictionary objects. Notice there's nothing special about LangChain in here. This is not a LangChain kind of thing. And this is kind of good because you can kind of think of, well, if you set up your own few-shot prompting, is like, what if I have that saved as a standard JSON file? And that's totally fine. You just have to define the schema, if you will, or structure of like how you want that to go into like the prompt that we're going to define here. In fact, let's go ahead and define that. So I'm going to call this few-shot schema. And then, so in order to use this, we are actually going to be using the same chat prompt template that we use above to start with. Now we're gonna build on top of this. So, don't get ahead of yourself here. This is not the end. So from messages, so we're going to pass in a list. So the first one is going to be the human. And then, so these are tuples here. So, and then the human. And then the second tuple here is going to represent AI. And then we're going to pass in the AI. Okay, so, and what this is basically tying to is saying, okay, for every single one of these things in here, we want to pass in this as if this one here is the human, and then this one is the AI. So we could change the names of these, and then we could change the names of these down here. So there is flexibility. It's not as if you have to always name it like this. I just did it this way just for clarity's sake. So that is the few shot schema. What did I do here? Dot from messages might help if I put that S. Okay, now we need to import another thing, yet another thing. All right, so I'm gonna. All right, so what is it? All right, so from LangChain dot prompts dot few shot import few shot from which one is it? Chat message prompt template. Some of these names could be a little bit long on LangChain, but yeah, they're a little bit long. So scrolling on back down here. All right, so the way that we can then use this here, so we need to pass in here. Let's go ahead and instantiate this object. So I'm going to call this. What do I call this down here? All right, so I'm going to call this our few shot prompt. Few shot prompt equals few shot message prompt template. And then so we're going to pass in our examples. So our examples are going to be exactly what we defined here above in this list of dictionaries. So I'm going to call this few shot examples. We call this few shot examples. So we'll paste that here. And then the next one we are going to put in is example prompt. And so I just called this the schema just because that's how it makes more sense in my brain to call this a schema or a structure than a prompt per se, because that's what we're doing is we're basically mapping this schema on top of this so then we can make use of it appropriately. All right, so there we go. And then we need to do one more thing. So we need to do another chat prompt template. I'm going to call this final prompt. So I'm going to call this final prompt equals chat prompt template. All right, and then we need to pass in a list again. So we need to pass in our few shot prompt, which we just defined in the cell above, and then we need to pass in a human object and then we're going to call this input. So this is, if this doesn't make sense, it'll make sense here in a second. So, and then it might help if I put the two messages or from messages there. From messages. All right, there we go. All right, final prompt. All right, so we are already instantiated our LLM. We're going to use this exact same LLM up here, Chat OpenAI. And so now we are finally ready to make use of this? I feel like I'm missing a piece here. Nope. All right, so let's go ahead and we're just gonna make use of this directly, I guess. So that we're gonna call LLM here. Now this is the one thing that's a little bit confusing about LangChain is sometimes you do like LLM.run to actually run things, or sometimes you just do LLM and then nothing. And so in this particular case, you don't do anything. That's the only thing I found that's a little bit quirky about LangChain here, is that it's a little bit inconsistent with those things, but it's okay. So we're going to call this final prompt dot format because we want to pass in our actual comment. So input equals David, and then we actually on this final prompt object we need to transform it to messages as such, to messages as such in order to actually see the results. All right, so let's go ahead and run it. What did I do here wrong? Did I not run the cell? All right, so final prompt dot. All right, message equals. Hold on, I think I did something wrong here. I'm trying to. Format prompt. Duh. Format prompt. There we go. What do you mean your messages equals? All right, so let's go ahead and run this. All right, there we go. So we've, again, recall, we did every time we say David, we give it some examples. I actually realized that I actually even screwed up the prompt here because we're not technically doubling the number of times we're saying this. We're actually just adding one more. Like, so doubling would be 2 Davids, 4 Davids, 8 Davids, basically 2 of the X Davids. And whereas, but it did it correctly. Like it still matched per the prompt template. So like you could see that we got 5 Hundleys out of here. So 1, 2, 3, 4, 5. So pretty cool. And that is how few shot prompting works. Okay, so we're moving a little bit faster. Maybe we will get through everything today. So that's few shot prompting. So what we covered? So we've covered chat bot interface with a custom tone. We covered few shot prompting. Let's move on to another cool topic. All right, so I'm going to call this one routing based on prompt. Okay, so let's say you have a situation where, based off of the user's input prompt, whatever they have to say, you want a different template to be applied to it. So just to keep things kind of simple for our sakes, we are going to be using another silly example. So we're going to have a prompt that goes to two different routes and then a default route. So, or two different routes than a default route. So the default route is going to be if, basically if it doesn't match any of these other templates, just return like a normal kind of thing. So the two routes we're going to do is, so the first route, again, sticking with the Jar Jar theme, is any questions that we ask about Star Wars specifically, we want answered as Jar Jar Binks. Number two is if we want to ask any questions about the Harry Potter series, we're going to have the LLM give the response back as if it is Hagrid. So I'm not even going to try to do a Hagrid response. But if anybody's read the Harry Potter books, he's got a very, J.K. Rowling gave him a very distinct speaking style, even like with how she wrote down like his words, because it's one thing to say it on the screen, and I can't remember the actor's name. He did a fantastic job though. But if you read the books, like J.K. Rowling very much stylizes Hagrid's writing in a very specific way, and you will see that here in a second. So again, if we ask questions about Star Wars, it goes to Jar Jar. Any questions about Harry Potter goes to Hagrid, and any questions about anything else just is generic. All right, so how do we do this? So the first thing that we need to do is we need to set up our templates. I'm going to call this Jar Jar template. Jar Jar template equals you are Jar Jar Binks from Star Wars. Please answer the following question as Jar Jar. And then I'm going to put input. Okay. Now, basically the same thing here for Hagrid. So I'm going to call this Hagrid template. Hagrid template equals you are Hagrid from Harry Potter. Please answer the following question as Hagrid. And then we're going to put input once again. Okay, so you might be wondering, we just instantiated these templates, but how does it actually know that we want it to go to Hagrid if it's a Harry Potter question, or if we want it to go to Jar Jar if it's a Star Wars question? So that is where we're going to do, we need to instantiate another list object, but this, and then so what we're going to do here, and this is actually, I'm just following LangChain's guidance here. You could probably streamline this a little bit, is we're going to create a list of dictionaries, and each of these dictionaries are going to represent how we route our prompts. And then we're actually going to have to reformat those dictionaries in different ways to actually make use of it in this capacity. But let's start off simply, and then we'll show how we're going to parse this stuff out. So I'm going to call this prompt matching template. Doesn't have to be called this. It can be called whatever you want. I just like it to be pretty clear. So again, we got a list of two dictionaries. So this first one is going to represent the name is Star Wars. All right, and then I'm going to say description. So this is how it knows. So this description specifically here is will tell us how to route the prompt. So this is we're going to call this useful for answering any questions about the Star Wars series. Okay, and then the prompt template is the Jar Jar template. Okay, so that's number one. All right, let's go ahead and do the same thing for our friend Hagrid. Name, I'm going to call this Harry Potter. Harry Potter. All right, description. Oops. Accidentally went a little bit crazy there. All right, by the way, this description here is a semantics description, meaning that there is not like a specific syntax you have to follow here. Like this could be read whatever you want, but I'm basically just following the guidance from LangChain, and I found it to be effective. So this useful for oops, I guess I should have put ing. In fact, I'm just going to copy this on down. But basically, this is how they recommend it. This could be longer for you. It could be shorter. It doesn't really matter. About the not Star Wars, Harry Potter. All right. Comma, prompt. Now remember, we're going to pass in our Hagrid prompt Hagrid template. All right, there we go. All right, just looking here. All right, so now we need to parse out this information into like different things that we can make use of for our actual routing thing going on here. Okay, so we're going to first instantiate an empty dictionary. We're going to call this destination chains equals an empty dictionary. And now we're going to iterate through these and then basically pull out all the information that we need for this destination chain appropriately. In fact, you know what? I'm just going to copy and paste this because this is a tiny bit long and it's really just a basic for statement. There is a prompt template that is shoved in here. I guess we do need to import yet another thing that I forgot to import. All right, so this time we need the prompt template. Where's the prompt templates? Is it just here? Sorry. Hold on. From LangChain dot prompts import prompt. Yeah, there we go. Okay. All right. So here, let's go ahead and look at what went on here. So destination chains. All right. So basically, what we did here is we pulled out each of these things into its own LLM chain and whatnot. And yeah, so we're basically giving a. Did I call this correctly? Okay. All right. Let me pause and collect my word for a second. All right, so what's going on here is we're grabbing the name and the prompt template. We are establishing a prompt template around it. And I guess this is the one thing that you do need to be a little bit careful of. And another, I don't know if it's a quirk of LangChain or not, how often they differ between chat prompt template and prompt template. Like they are distinct objects. They do different things, and it can be a little bit confusing on when to know what. Or when to use what. So in this case, because we are not using a chat interface here per se, we are just using the standard prompt template and not the chat prompt template. So you can see here, just grabbing all these things, setting our input variable, because recall we do have our input that will go here. So basically when the actual LLM is run, it's going to run this first, and then we'll run our question. And then we set these into a dictionary. So, okay, so that's all good to go. All right, so let's scroll on down. I'm scrolling on my other screen here. Oh, we do need to set a default chain. So again, if one of these chains does not match, it goes to the default chain. So I'm gonna call this default chain equals conversation chain, LM equals LM, output key equals text. All right, so that's the default chain. Okay. All right, so I want to load up something here because this is all right, we got another thing to import. I know we got a lot of. This is a busy stream. Like but this is all good stuff. Like I hope you're enjoying it as much as I am. So we need to import. There's a lot of constants in LangChain here. So what I mean by constants here is let's go ahead and let's show this. So this is basically a long string. I wonder if I can do this if I did there we go. So this is basically a long string, and you can find this interspersed throughout all LangChain here. So this is how we are going to be doing the multi-prompt routing template. Is basically you could see how we have here like our inputs, our destinations and stuff. Basically the way that we are actually doing the routing is it's using the LLM along with this custom prompting to know like how to forward these along well. And you might be wondering, does this sort of prompting work all that well? And the answer is yes. And this is another encouragement of why I encourage you to use LangChain and not necessarily try to build something on your own, is because I actually don't have much. I actually know for a fact these are tried and true prompts because I had an issue with one of these last week, and I went out to GitHub and I saw people chatting about this specific one like at length. And so these, again, you could probably figure these things out on your own, but why reinvent the wheel when the wheel's already there? That sort of thing. So we do need to basically inject our stuff into this template, and the way that we do that is a little bit funky as well. Not difficult, but a little bit funky. All right, so we're going to call this, we're going to set a new object here, or a new variable, destinations. Here, let me clear this out so you're not confused. All right, so we're going to call this destinations equals, all right, we're going to do a little bit of f-string formatting here. So f, p, name colon p description for, I feel like I have an extra curly brace in here somewhere. P name, oh yeah I do, or I forgot to put it around this part here. All right, so we're grabbing this piece here, just the name and description from up here, so name description. This looks funky, but it'll make sense here in a little second. So for p in prompt matching template. Okay. Yeah, it might help if I put some quotes around this, because this is an F string. Oh, I hate it when I do that. Intermingling double quotes and single quotes like that. Shame on me. All right, there we go. All right, so if we look at this, let's go ahead and look at this really quick. Destinations. All right, so you can see here we got exactly what we needed. Now we just need to conjoin these together and shove it into the template. So the way that we do this, we're going to call this router template. Template equals this long thing dot format. Destinations equals I'm going to call this new line join dot join destinations. Okay, so basically what that did here was it took this list, jammed it as a single string, but also put a new line in front of it. In fact, let me go ahead and show you let me show you how I did this, like actually in the notebook. So equals n dot join destination string, and you can see boom right there. And then, well, it's not printing out the well. Let me print this. Print this. Okay, so that's basically what we're passing in, and let's run this, and let's go ahead and output it just for fun. Destinations. Did I spell that wrong? Destinations. All right, there we go. Very good. All right, so might help if I printed this. Router template. All right, so this is the template that we're going to be passing in, but there is a special object that is being used here as well. Now, we do need to set this up as a template before we can actually pass this into that special multi-prompt chain. So what we're gonna do here is I'm gonna call this. Did I call that router prompt? Oh, I called that router template. I'm gonna call this router prompt. Router prompt. In fact, let me scroll up a little more. Router prompt equals prompt template. Template equals, so we had the router template from above, router template. We need our destination chains that we defined above, and we need our default chain. Default chain equals default chain. So nothing fancy going on here. All right. I guess I don't need commas here. I get confused when I need things or when I don't need things. Hold on, what did I do here? Oh, I forgot to pass in the input variable. Oh yeah, I'm doing things out of order. Oops. All right, delete what you just did. Sorry. All right, template equals router template. Okay, so that part was right. Input variables equals input again, because we're going to be injecting things into here as so. And output parser equals, and we're going to talk a little bit more about output parsers in a little bit. We do have another import that we got to do here though. All right, and yeah. So we'll just talk about it right now. What a parser is basically it's a programmatic way to extract information from a string returned by the LLM into something that you can actually use by a computer. So in this case, it's parsing this out into, I think, a JSON object that will be passed into like the next part. Like, okay, so what does it do here? So, okay, so basically we got two parts here going on the router chain. So the first part is it's basically just trying to figure out which prompt to route it to, and then it will say, okay, like if it's let's say I'm asking who's Anakin Skywalker, so it's going to say, okay, who's Anakin Skywalker? That looks like a good LLM route is going to say, this looks like a good option for sending it to the Jar Jar template. So we'll send it there, and then we do an LLM call again saying, okay, you are Jar Jar Binks. Answer the question, add Jar Jar Binks, who is Anakin Skywalker, and then we get a response back. So the output parser is sitting in between those two, basically saying, okay, once we figure out where the route needs to go, I'm going to parse this out as a JSON file, and we'll send it on over to the other thing. And this will make sense here in again, whenever we start to see this a little bit more. So another import. So what is this one? So this is from LangChain dot output parsers. Oops, no, not output parsers. Where is this? From LangChain dot router dot multi LLM, or no, I'm sorry. From router dot LLM router import router output parser. Router output parser. Why is this not showing up as LangChain? From LangChain dot router. Oh, LangChain dot chains dot router. There we go. I was trying to figure out why the syntax highlighting was not showing up there. Oops. All right, so, and I got an extra thingy in there. All right, so that's, I think, all we need to do for that piece. Let me scroll down on my notes here. I'm glad I took notes. Oh my gosh, there's no way I'd be able to get through this stream without notes today. All right, so now we are ready to, we need to instantiate some more, bring in some more objects. All right, so we're gonna bring in the router chain, and then we need to bring in the multi-prompt chain. So what is the multi-prompt chain called again? So yeah, lots of imports going on here, but again, we got a lot of stuff going on in this notebook. You wouldn't have this much going on in a typical production, whatever. All right, so we're gonna import those two. All right, just taking a breather there for a second. All right, so now that we've instantiated that, let's go ahead and instantiate what is called the router chain. So this is the router chain equals LLM router chain. So like I said, this is going to be the first thing that it goes to, from LLM, and then this is going to be LLM router router prompt. Okay, so we're going to pass in those two. So LM equals LM. In fact, let me just make that clear for you. LM equals LM, prompt equals router prompt. All right. Now we are ready to build the multi-prompt chain. So I'm going to call this multi-prompt chain equals multi-prompt chain. And this is basically going to hold everything together. So we're going to call this router chain. Router chain equals chain. Oh my gosh. Chain equals router chain. And now this is where I was starting to overlap my notes here. So destination chains equals destination chains. And then default chain equals default chain. Very good. All right, now we're finally ready to make use of this guy. So I'm gonna just copy and paste this stuff here. Again, this is just going to be invoking the thing. So we got 3 different prompts here. Let's work our way from the bottom up. So we got our generic prompt. So just in case there is nothing to route against, which in this case there would not be, because we're asking again, what is the capital of Illinois? We will get back a generic response. But if we ask a specific Harry Potter question, like who's Hermione Granger, or a specific Star Wars question, like who's Anakin Skywalker, we should get back the responses correctly. Now, as this is running here, I do want to jump back over to Langsmith just to show you that this thing works in pretty much real time. So if this is our notebook that we've been doing here, and you can see as it's running over in my notebook here that these things are going on even as we speak right now. And so, yeah, it just refreshed, and there is our 3 multi-prompt chains. And so if we wanted to look at these, and then you could see that, like, let's look at this this router chain specifically here. So basically, we asked the question, who is Anakin Skywalker? And the output here was this parsed version of like basically saying, okay, destination is Star Wars, and then next is who is Anakin Skywalker. And so if we come back to here, then like we want to look at the final results, then you can see here that the text is like there's the Jar Jar one again that we're so used to. And then if we want to look at like the Hagrid one, here's Hagrid. So you can see here, again, do not try to get me to do that accent. Like I have gotten burned from trying to do accents before, not because I've tried like I'm trying to be like inconsiderate or anything. It's just because I'm so bad at doing them. Like, okay, so yeah, there was one time I was in a meeting like a year and a half ago or something like that, where if you've all seen the TV show Ted Lasso, you'll know like there's oh my gosh, I can't even remember his name now. There's like the gruff like character who you know, he's got short hair, thick beard, very distinct sort of accent. I tried doing that in a meeting one time, and it came out so bad that like that was probably one of the most embarrassing things I've ever done. Like, I'm sure if there's somebody from my team watching this, will be like, "Yeah, I remember that. That was stupid." Okay, so yeah, so if we come back into our Jupyter notebook, we're going to see the exact same things here. I just wanted to highlight that again, just to throw another plug in there for LangSmith. Very cool how that kind of all plays out, and you could even it's got a share button up here and everything, and I do want to play more with LangSmith. I just don't know a whole lot about it right now. Okay, so that is prompt routing. So you can see here it did route the prompts just like we wanted to, and it did get back the response just like we expected. Capital of Illinois, Springfield, and no special formatting here. All right, so all right, what do we have left? Oh, very good. We only have one thing left, and we've been going for an hour. I usually don't like to go too much longer than an hour or so, and this last one's not too bad. This one's going to be a little bit of a fun one, and we're going to call this one, and it's actually going to feed right into what we were talking about in terms of output parsing, because we are going to talk about output parsers. And in fact, if I would have thought about this earlier, I probably should have done this one before I did that last one, but it's okay. I think y'all are following along just fine. Again, any questions? I am monitoring both LinkedIn and YouTube for questions. I don't see anything, but so we'll continue moving on. So we're gonna call this section. Output parsing. Okay, so what is output parsing? So output parsing, again, if you recall, I did a stream a couple weeks ago where and a blog post that demonstrated specifically how with OpenAI, how we could pass in our own schema of like a JSON schema of how to necessarily export the response into a structured object that we can make use of. And that is more or less what output parsing does. Now, it actually might be the exact same thing, and I'm just not aware of it because OpenAI actually abstracts away like what it's actually doing behind the scenes. So I will tell you, output parsing in terms of LangChain is specifically doing this with advanced prompt engineering. In fact, let me go ahead and demonstrate this for you, if I can, because I think I need to do another import here, but I'm trying to remember what I need to import. Oh, the list parser, or no, it's not. Well, it's not called a list parser. So I'm gonna from LangChain dot output parsers import comma separated list output parser. So that what this one is very specifically designed just for outputting things as list. We'll talk a little bit more about other parsers after we show this one. We're just going to keep this one simple for now. Okay, so I'm going to import that. And in fact, so let me go ahead and show you what I'm talking about. So output parser equals, hold on, or I'm going to call this list parser, I guess. List parser equals, comma. All right, so list parser, I don't remember the specific command. I think it's prompt. There's like a specific way you can actually get it to show like what the template is, but I don't remember what it is now. Let's see. One of these has to be it. I could just look it up. Stream, transform, validate. I don't think I'm going to find it. But basically, with any of these... oh, there it is, right there. Get format instructions. Yeah, there we go. Your response should be listed, separated as list of comma separated values. So this is a very simple one. There's more complex ones than this. But then not only is it going to output the actual response in the way that we need it to, but we can actually use this same formatter to actually format it into an object that we can make use of here correctly in Python. So let's start off. Let's just get a simple LLM chain going. Ignore this for now. So I'm going to call this LLM chain equals LM chain. LM equals OpenAI. Uh-oh, I think I got to do another import. Yep, I got to do one more import here. I think this should be the last one, though. Maybe not. Lots of imports going on here. All right, but we're introducing a lot of good stuff here. All right, so I'm going to call this LM equals OpenAI. Again, this is not the same chat interface that we did above. So if you recall, that was called Chat OpenAI. This one's called OpenAI. Yes, they are different. Just again, be mindful of those little gotchas there. All right, so I'm going to call that, and then we're going to instantiate a prompt. Prompt equals prompt template, not pending deprecation warning. Prompt template. Template equals in question. And then input variable. What did I call that? I can't see in my other screen, so I'm just going to pull up my notebook, my other notebook. In fact, I'm just going to copy this over because I'm getting a little bit lazy. All right, there we go. Just to make sure I have it all right. So, all right, so what's going on here? Let me collapse that again. All right, so we got the LM chain that we're instantiating, and we're just passing in a very, very, very simple prompt template. In fact, it's basically a non-template. So let's say I wanted to use this. I'm going to say LM response equals LM chain dot run, and then let's say who are the 5 main characters from the TV show Friends. Okay, so if we, and then let's print out the response. Print response. All right, so we're just asking this very generically. All right, so these are the 5 characters, and you can see that it's a numbered list. Now, this is technically a string, but let's say I wanted to get this into a list format, something that I can programmatically interact with Python. So this is exactly where our parser comes in. So let's reinstantiate this LM chain object, but we're going to do something a little bit different here. So LM chain equals LM chain. And this time, so we are going to keep using the same LM, of course, which is OpenAI. We are going to set up another prompt template. Prompt template. I'm doing a little bit of a different format here, just so you know things don't get all squished together, because this is where things are going to change a little bit. So template, we are going to ask the question in curly braces, question, new line, and then we are going to pass in format instructions. Okay, and you might be wondering, where does this come in from? All right, so it'll come in down here. So input, but after this first one. So input variables, again, nothing new here per se. Question, I guess everything's new for us since we're covering this all today. All right, so input variables equals questions, and then all right, so partial variables. So this is the thing that we need to pass in. Partial variables. I actually don't understand why this is separated out as such. I'm just following the LangChain documentation, so this one is a little bit confusing to me, but it works, so I'm not going to argue it too much. All right. So format instructions, we're going to get list parser dot get format instructions. Oh my gosh, they were there all along. All right, so that is the actual chain itself. So now let's go ahead and rerun this exact same prompt. So response equals LM chain dot run. Who are the 5 main characters from the TV show Friends? Okay. And then let's go ahead and print the response, because I'm intentionally going to try baffling you here. Okay, so what you might be wondering here is okay, this looks kind of right, but this doesn't look like a Python list object. And the reason for that is after we get this response back, we actually have to pass it back through the parser object one more time, and that will actually give us the list that we need from this thing here. So the way that we do that here is taking our parsing object, so list parser dot parse, and let's go ahead and parse out the response. So response, and now we actually have a formal Python string. So in fact, let's go ahead and call this friends list equals that. So if I want to look at, okay, who's in the first slot there? Friends list equals, or friends list 0 is Monica, and you know, if I chose 3, well, there's only 4 of them, Joey, and then so now we can programmatically interact with all these in different ways. Okay, so that's just one parser. I'm not going to show the code for any other parsers, but I do want to show the documentation of them just so you can be exposed to it. All right, and by the way, the documentation for LangChain is very good. Very, very self-explanatory, very intuitive. Big fan. All right, so let's go over here to the output parsers. So we have like some specific parsers. So we used a list specific parser. There's a datetime parser and other things. If you wanted to make your own parser, very similar to the OpenAI function calling kind of thing, you can. You would just define it as such. You would just have to, you would have to import this response schema kind of thing and this list object here. And you would basically say, okay, for this response object, I want it to be the answer, and I want it to be the answer is the user's question, blah blah blah, and then you can get very custom things out of here. Now I do believe that there's an additional parameter in here that I don't believe they added. I don't know why they didn't add that here. So you got name, description. There's a third one here that's type. So if you wanted a specific data type, you could get it this way. So if this list object's a little too simple for you, or you wanted something more complex, you can do that. And this page shows you precisely how to do that. Oh my gosh, that was a lot of material today. So I am going to end things off here. So that is just a few things that I wanted to cover today in terms of LangChain. Like I said, this is definitely not the end of LangChain. I want to dedicate a full stream to, or maybe a couple streams to, like how to use like vector search with vector embeddings, but that might be its own thing, and then how to do that plus LangChain being another stream. I just think those two topics are too big for a single stream, and obviously we've been going for almost 75 minutes already. Let's call it here. So it's, I don't know, like this. I hope you enjoyed this stream. It's really cool. LangChain is probably the funnest I've had with learning a Python library in years. Like, it's a really fun library. Harrison Chase and the folks over at LangChain, they're very responsive. I really appreciate them. So I would definitely encourage you to look it up. And like I said, folks like Andrew Ng, don't take it from me. Folks like Andrew Ng are using it. I saw a chart on Twitter this morning. In fact, let me pull it up. I'm gonna, just to show you, like, it's so interesting to me, at least. All right, so I keep saying Twitter. My apologies. It's X. All right, so I think it's right here, by this person right here. So you can see. Oh, might help if I was sharing my screen again. All right, bottom right. All right, so this is the graph that he created, and he's just showing some of the Python libraries up here. So this is on the x-axis. You can see how many things were how many times it was downloaded this month, versus on the y-axis, you can see how many times people start it. So this is all the Python packages that he associated to generative AI, and you can see that we got a couple of down here that are clumped together, but far and away you got LangChain just chilling out over here on its own. Similar to, and then these are the I don't want to say generic machine learning libraries, but like the standard machine learning libraries. Of course, I can learn it so far on away over here, and I'm kind of surprised that Hugging Face isn't a little bit higher. Like, it does make sense that the stars are higher. I'm surprised like the downloads are higher. To be completely transparent, I'm surprised TensorFlow is this high still. Like, if it feels like everybody's going Torch these days, or even now in the last week or so, Keras with a Torch backend. Interesting, but yeah. So LangChain's really cool and really popular. Like, basically, don't take my word for it. All right, so that's all I want to cover today. Hope you enjoyed the stream. Hope you have fun playing with LangChain. And again, about the agents, maybe we'll get back to a topic about agents. I don't know. I guess the one thing I'll say about agents, we'll end on this. I don't trust them. Like, even if I could get it to work, I just don't trust them. Like, not in this day and age. Like, not yet. Like, the problem is that it's like the children's game of telephone. So the children's game of telephone, where everybody sits in a circle, and then one person says a message, and then you whisper it in the ear, and then hopefully by the end of the circle, the message is intact, and it almost never is. And that's the problem with hallucinations and agents, is like, if you have one bad thing in the middle there, one hallucination in the middle, then your whole thing is garbage downstream. So I actually like, for a real business world context, like, maybe there is a use case for it in like research or like legal discovery, something like that. I don't know, but otherwise I don't think I'd ever recommend agents for a production setting, at least not until these LLMs or AGI come along and can really tamp down those hallucinations. Not to say that they're not cool. Like, they still are cool, and I still want to get one working, and I will have another stream if I can get one working. It's just kind of risky, but anyway. All right, so let's go ahead and end it there. I hope you all have a great weekend. Thank you again for watching, and we'll see you in the next one.